Well, good morning, everyone. This is Charles Ely, and welcome to the seventh session on the COMNET modeling guidelines and procedures. So this is session 7. Today we're going to begin covering chapter 6 of the COMNET modeling guidelines and procedures. Chapter 6 is the longest and most detailed chapter in COMNET. Today we're going to cover the first 3 sections: the overview, project data, and thermal blocks. Next week we'll cover spend the whole time on space uses, because that gets into a lot of detail about how we handle daylighting, plug loads, and various other things. So beginning with section 6.1, there's 3 parts here, and as we go through it, I've created a little gray box on the right side of the screen that shows where we are in the document, so you can follow along. Section 6.1.1 defines what we mean by building descriptors in COMNET. A building descriptor is basically a piece of information that would go into the model. We've tried to keep our discussion of the building descriptors generic. We've avoided using DOE to BDL or any other language that's specific to a particular software. So what this diagram shows, it's really kind of a schematic of what COMNET compliant software would look like. The building descriptors are defined in terms of both the proposed design or the rated building and the standard design, or what we're calling mostly the baseline building. These building descriptors then get translated into the native files, or the format that's used by the simulator. This would be BDL for DOE2, IDF for Energy Plus. The proposed design, or the rated building, and the baseline building are then simulated. The results are summarized, and the COMNET output reports are produced. Section 6.1.2 is a very important section of the COMNET manual. This has the HVAC system maps. These maps are really from the 90.1 performance rating method, and when we support the 2010 version of 90.1, this mapping has been modified some. So you begin on the left side, and the first question is, what type of building is it? Is it residential or non-residential? If it's residential, then the next question is, what is the heating source? Is it gas or electric? And then if it's gas, then you get mapped to your baseline building system would then be a packaged terminal air conditioner system with a boiler for heat, DX cooling, constant volume fan, and so forth. If you go down the other way and you answer my building is non-residential, then there's another question, which is building size. And really there's 3 sizes: small, medium, and large. A small building is one that's 3 stories or less, and also less than 25,000 square feet. A large building is more than 5 stories or more than 150,000 square feet. And a medium building is one that's neither small nor large by these definitions. You then ask, what's the heating source? Is it gas or electric? And then this maps you to one of the HVAC systems. These, as we go through the HVAC portions of the COMNET manual, and we define the baseline buildings, there will be many references back to this figure. Each building descriptor in COMNET is treated in a similar manner. There's really 5 sections. The first describes the applicability of the building descriptor. When does it apply? Then that's followed by a definition of the building descriptor. We describe what the units are when that's applicable. And at present, COMNET only supports inch-pound units. The 4th section describes any kind of input restrictions for the purposes of green building ratings and tax credits. Often things like schedules or occupant loads or plug loads and so forth there's restrictions on what can be modeled, and so that's discussed there. And then the last section has the rules for defining the baseline building. So there's about 550 building descriptors, and they all are organized in the same manner so that we don't have to figure out a different organization each time. One other thing to note is that the applicability, input restrictions, and baseline rules associated with each building descriptor actually vary with the supported purposes. There's some other classifications that we use for building descriptors. Some building descriptors are what we just call references, and this is general information that does not affect the energy performance of the rated or the baseline building, things like the name of the architect. An asset is a building descriptor that's different between the baseline and the rated building, and therefore affects the outcome. It affects the difference in performance between the rated building and the baseline building. Neutral independent building descriptors are ones that are prescribed and must be the same for both the reference building or the baseline building and the rated building. Examples of this would be schedules, for instance, are neutral independent variables for tax credits, but for green building ratings, they would be neutral dependent. Neutral dependent means that they're the same between the rated building and the baseline building, but the value or the input is derived from the rated building. And these classifications also change with each purpose. So a particular building descriptor might be neutral independent for tax credits, and it might be neutral dependent for green building ratings. All right. The building descriptors are also listed and summarized in Appendix A of the COMNET manual, and this is an Excel spreadsheet actually that lists all the building descriptors, and it has the columns have characteristics of those building descriptors. So some of you may find it more handy to look at Appendix A, but there should be the same number of building descriptors in both places, and they should be the same. Okay, let's start with Section 6.2, Project Data. And we're going to cover the 6 parts here. General information is pretty straightforward. These are all reference building descriptors, and they include the name of the project, the owner, the architect, the engineers, the energy modeler, and the date. Pretty straightforward information. Does not affect the outcome in any way. The next section are what we call the baseline standard. And the baseline standard is really determined by the purpose. So if it's tax credits is your purpose, the baseline standard is 90.1 2001. If your purpose is green building ratings, then the baseline standard is 90.1 27. There's some other things too. The method used to calculate percent savings is also different by purpose. When you're doing tax credits, you only look at the regulated energy, basically heating, cooling, interior lighting, and hot water. But when you calculate percent savings for green building ratings, you look at all of the energy, including process, plug loads, commercial refrigeration, everything. The next section is geographic and climate data. The building descriptors are things like zip code, latitude, longitude, the thermal zone and moisture zone from the DOE classifications, the time zone, whether or not daylight savings is observed, the city, the state, county, and city where the project's located, the weather data that's used for simulation, and also ground reflectance is lumped into this category as well. The next section is for building site characteristics. This is basically shading elements around the building site from neighboring structures, terrain or mountains, vegetation, and also self-shading by the building itself. So shading from neighboring buildings can be modeled with COMNET, but it is a neutral dependent variable. That means that it applies equally to both the rated building and the baseline building. The calendar basically identifies the year of analysis, 2011, 2010, whatever. The purpose of the specifying the year of analysis is so that we know how weekdays and weekends align with the weather file. This could make a little bit of difference. It's neutral and dependent, so it's whatever you put in is going to be the same for the baseline building. The year of analysis, of course, cannot be a leap year, because that would the weather files all have 365 days of weather, and it would throw the simulation off if you specify leap year. And the calendar section also has a schedule of holidays. COMNET has defaults for the holidays, but you can put in whatever holidays are observed for the building you're modeling. And that input is neutral and dependent, which means that the baseline building assumes the same values. The energy cost is a metric that's specified by the 90.1 performance rating method. It's so when you're doing tax deductions and green building ratings, it's cost that you use. Keep in mind that COMNET does provide some default time of use tariffs. Those were reviewed in the last vetting session, number 6. When you're using COMNET for Energy Star, however, though, the metric is EPA source energy, not cost. So here you can, where the simulator needs to be able to support the time of use rates that COMNET specifies as defaults, and also local utility rates, including demand charges and all the other interesting features associated with electricity and gas rates. Moving on to section 6.3, these are the thermal blocks, and again, we're going to we're going to go through each section, and you'll be able to follow along by looking at the little gray bar on the right side, and the arrow and the highlight will show you where we are in our presentation. So starting with general information, basically each thermal block would have a name of some sort and perhaps a description. There would be a block type associated with it. This is really a 90.1 feature. Every thermal block needs to be designated as directly conditioned, which would be most of them, or indirectly conditioned, which would be, for instance, an enclosed stairwell that doesn't have a direct source of heating or cooling, but is basically heated or cooled by its proximity to other conditioned spaces. A thermal block can be unconditioned, for instance, a basement or a parking garage, or it can be a plenum. So those are the 4 block types that are represented. If a simulator recognizes some other block type, that's okay too. There would be the name of the system that serves the thermal block. This is a way of connecting the thermal blocks with the systems that serve them. Some software applications may do this in other ways, and that's okay. But we need to know the name of the system that's serving the thermal block. Then we need to know the occupancy type. This too is a 90.1 classification. And we need to know the occupancy type, which is either residential, non-residential, or semi-heated. This is needed so that we know which building envelope tables to look into for specifying the baseline building. And then finally is the floor area. But the floor area, like many other thermal block properties, is derived from the spaces. Moving on to interior lighting, mostly we're going to cover interior lighting when we get to spaces. So what happens at the thermal block level is that they're basically summed up from the spaces. So if a thermal block includes 2 spaces and one has 500 watts and one has 5,000 watts, the total lighting power for that thermal block would be 5,500 watts. Sometimes the summation can get a little complicated and may need to occur at each time step. This would be the case if you had a thermal block where part of it is daylighted and part is not, or if you had a thermal block with spaces that have different schedules, or let's say some spaces you've made adjustments for automatic lighting controls, or some combination of those. You can still sum, but it might be necessary to do it at the time step level. Moving on to receptacle and process loads. Again, these are specified at the space level, and at the thermal block level, you just add up the power and integrate the schedules for the thermal block. You would face some of the same issues here as with lighting if it may be necessary to do the summation at each time step when there's different schedules, or when adjustments are made to account for energy efficiency measures. And then moving on to occupants, same situation. Data is the number of occupants, and the schedule of occupants is all specified at the space level, which we'll cover next week. And what happens at the thermal block level is that they're summed. Remember from a previous presentation, I believe this was vetting session 2, we provided some rules on when spaces can be combined into a thermal block. And the rules are that they use the same operating schedule or substantially the same operating schedule. They have the same temperature settings, similar internal loads, and similar occupant densities. When these rules are followed, summation of spaces within thermal blocks should be a fairly straightforward process. Moving on to infiltration, this is where it begins to get a little bit tricky. COMNET recognizes different ways to model infiltration, including the effective leakage area, the component leakage area, air changes per hour, or any other method, for that matter, that software wants to implement. When you're doing tax credits, the component leakage area method is specified, and infiltration for both the rated building and the reference building or the baseline building is set at 0.38 CFM per square foot of surface area, and a schedule for infiltration is prescribed, which is basically the inverse of the HVAC operating schedule. With green building ratings, the method is neutral dependent, so you can use any method you want to model infiltration, and you can also make different. You can specify different data or different schedules for the rated building and the baseline building. Moving on to natural ventilation. There's a couple of requirements that come from the performance rating method. The first requirement for modeling natural ventilation in space is that it not have air conditioning. And the second requirement is that there be fewer than 300 unmet load hours in that space. So when it's modeled under the conditions of natural ventilation, it should maintain comfort for all but 300, no more than 300 load hours. When these conditions are met, then the thermal block is modeled with no air conditioning when natural ventilation is able to maintain comfort. For those periods of time when natural ventilation cannot maintain comfort, then a baseline building air conditioning system is assumed for the rated building, and fans cycle with loads, but they run continuously in the baseline building. There are basically three very general building descriptors for natural ventilation. One is the natural ventilation method, and this really depends on the capabilities of the software. What I suspect most people will be doing for natural ventilation is doing some type of outside-the-box calculation using CFD or computational fluid dynamics, and then making an input to the airflow rate or a schedule for airflow rates that show what the ventilation rate is when the windows are open or the ventilation apertures are open and when they're closed, and then this would be modified by a schedule. I've had some success modeling natural ventilation in this manner. Other tools like Energy Plus has COMNET as a feature of the program, and that of course can be used as well. All inputs, of course, are critical defaults, which means that if you do these outside-the-box calculations, it's necessary to document where the inputs came from. And finally, thermal mass. Now, what we're talking about here is not the thermal mass associated with building envelope components, because those are specified through the layers used to define walls, roofs, floors, and other envelope components. What we're talking about here is the is the thermal mass often specified in pounds per square foot for furniture and contents. And this, for some simulation programs, this is just default. It's neutral and dependent for both tax credits and green building ratings, which means that whatever you put in it's neutral. It doesn't count for you or against you when you do your model. So that's a quick run through of sections 6.1, 6.2, and 6.3. You of course can get more information by visiting COMNET.org, and you can contact me at this address or Mark Cherniak at New Building Institute. So with that, I'll wrap up vetting session 7, and we can have some questions and discussion.
All right.